Hi everybody, welcome back. There is a little bit of stuff I want to emphasize in section 6.4, which is titled Rational Exponents. I'll get into that title in a second. You might already understand what that's getting at, but I don't want to spoil the punchline right away. So check this out. Simplifying expressions with rational exponents. Well, this is actually a pretty big thing for you going forward, okay? I don't know if you were aware of this, but the square root of 25 is actually equivalent to 25 to a certain power, okay? In other words, there is a certain power, an exponent, that if you raise 25 to that power, it means the same as a square root. So what power actually means the same as a square root? That's the big idea, as well as like third roots, fourth roots, but this is pretty much the big idea of this section. So I don't know, did you know that the 1/2 power actually meant a square root? I mean, maybe you did. You probably didn't, though. But that is something you absolutely should be aware of. You know, again, in this time of distance learning and everything, and me having to pick and choose what I absolutely need to cover with you, and hopefully you guys can get exposed to, and hopefully, put in your long-term memory banks. This is one of like my top picks, okay? The fact that knowing that a 1/2 power means the same as a square root, that is definitely big, okay? And then likewise, the exponent that would mean the same as a cube root or a third root, I mean, take a guess. What power do you think that would be? Well, that would be a 1/3 power. So raising a 27 to the 1/3 power is the same thing as saying like the third root. And then, I think you see where this is going. The fourth root of 16 you could rewrite as 16 to the 1/4 power. So the title here, rational exponents. In math, oftentimes the word rational can go hand in hand with the word fraction. So, to summarize this first little big intro here, okay? A fraction exponent basically means you're doing a root, okay? These denominators means like a root, okay? A square root, a third root, a fourth root. All right? So that is big. So here's like the definition, like this is like the textbook looking definition. Like I said, something to 1 over n power would be like the nth root. But furthermore, like here's what this is getting at, okay? What this part's getting at is, the numerator is still a power. So what this is saying right here in purple is essentially like this right here. The 4 represents what type of root, this like if you have a fraction as a power, if your power is a fraction, the denominator of that power represents what kind of root you're taking, but the numerator is technically still a power. So it's like this, you're raising 16 to the 1 power, but at the same time you're taking the 4th root. And that's what this is basically saying in purple. So here, to simplify each expression, this would be like 216 to the 1st power, but also the 3rd root, which ends up being 6, And furthermore, people, your calculators you can totally punch into your calculator a 1/3 power. So your a lot of calculators will do this for you, typing in like 216 to the 1/3 power. Your calculator will tell you 6. Okay. Now this, I'm not going to focus too much on this. I mean, This is obviously the square root of 7 times the square root of 7, which ends up being basically 7, like we've been talking about. Root 7 times root 7 is just 7. This, well, I know I kind of really brushed past this in an earlier section, but these can be multiplied together. I'm not going to really focus a whole lot mostly on problems like this, but this ends up being the 4th root of 625, which is 5. It ends up being like 625 to the 1/4 power. Write in radical form. Yeah, I mean, I'm not gonna focus. This is not what I'm gonna emphasize the most. So, like I've already said, the 7 is like the root, but the 3 is still technically a power. You know what I mean? So this is like exponent form, and this would be called radical form because there's a radical symbol. Again, likewise, these are not the types of problems I think I'm going to be emphasizing on the homework too much or at all. Let's see here. What is going on here? Is this like a different problem? What is this over here, people? Oh, this was this. Oh, all right. This was a part of this problem because you see what happened here. You had a root in the denominator, and you're not allowed to do that. So what I was doing here was technically rationalizing the denominator because that's how your final answers are supposed to look. But once again, I'm not really going to emphasize this stuff. And this is going the other way. See, again, this is not what I'm going to be emphasizing here, but you could rewrite this the other way. Remember, we have a square root, but also a 5th power. So you end up with like a 5/2 power because it's a 2nd root, but a 5th power. Similar here, it's a 5th root, but a 3rd power. So you end up with like a 3/5 power. Okay. This is what maybe not so much this, but I am going to be giving you problems like number 2 and number 3. You know what I mean? So I'll move those boxes really quick. Convert it, and then what? Blah blah blah. But this, where it's just like regular numbers, so raising 16 to the negative 5/2 power. Well, first of all, that's going to first of all, we need to make that negative power positive. So please don't forget what a negative power actually means. You know what I mean? So we rewrite it like this. And now, okay, how do we do 16 to the 5/2 power? Just again, remember, this is the biggest thing I want to emphasize in this whole lesson, that when you have a fraction as a power, the denominator is like the root, and the numerator is like still a power. So we got to take 16 and we got to raise it to the 5th power, but at the same time doing like a square root. Now, this is something you might want to actually write down. What I recommend you do is I recommend you do the oh my god, I can't believe I almost said that wrong. Let me say that again. What I recommend you do is you do the root first. So we're going to take the square root of 16 first, then we're going to raise it to the 5th power. Okay? I mean, doesn't that make sense? I mean, why would you raise 16 to the 5th power first? Get like some crazy huge number and then do the square root. I say do the root first and then the power. So taking the square root of 16, you get 4. And then raising it to the 5th power, you get 1024. So the final answer here is 1 over 1024, because remember, the very first step, we needed to kind of make that negative power into a positive power. Here, it's already a positive power. So don't worry about this being negative. That's okay. So we're going to have to do like the 5th root of negative 32 and then raise it to the 4th power. So what is the 5th root of negative 32? Wouldn't that be negative 2? And then the fourth power would make it positive 16. So remember, the denominator of a power is like the root, and the numerator of that power is basically still a power.